Hello class, in this video I'll be showing you an application of right triangles. Let's begin. A straight trail leads from the base of a building, elevation 2,000 feet, to a scenic overlook, elevation 5,200 feet. The length of the trail is 11,000 feet. What is the inclination or grade of the trail? Okay, so before I begin answering this question, I'm going to draw a diagram, and I'm going to draw the base of the building first. So the base of the building is at an elevation of 2,000 feet. And then here's the building. The trail leads up to an elevation of 5,200 feet. And the length of the trail is 11,000 feet. And since this is an application of right triangles, and we don't have any right triangles at the moment, I'm going to create a right triangle by drawing this red horizontal line from the base of the building to the scenic overlook. And now I've created a right triangle. And the problem's asking, what is the inclination or grade of the trail? Well, the angle that's created by the trail and this horizontal red line, that is the inclination. And we'll just call that theta. And to find theta, we can use sine, tangent, or cosine. We just need to use the given information to figure out which one of those ratios would work best. So let's start by choosing cosine. So the cosine theta is equal to the adjacent side divided by the hypotenuse. Here is the adjacent side. However, there's no real good way of finding that side with the given information. So I'm not going to use cosine. Next, let's try sine. Sine of theta is equal to the opposite divided by the hypotenuse. And the opposite side would be this piece right here. Oops. And I feel that with the information that's given, we can easily find the length of that side. We know that this height is 2,000 feet, and then this height is 5,200 feet. So this piece that I'm about to highlight in red will be 5,200 minus the 2,000, which is 3,200 feet. So now we can use sine theta to find the inclination. So sine of theta is equal to the opposite side divided by the hypotenuse, which will be 3,200 divided by 11,000. Now you may remember from the inverse section that if sine of theta is equal to x, then theta is equal to the inverse sine of x, as long as theta is between negative pi halves and pi halves. Or if you want to do degrees, negative 90 degrees and positive 90 degrees. So I'm going to apply this rule to solve for theta. So if sine theta is equal to 3200 divided by 11,000, then theta is equal to the inverse sine of 3200 divided by 11,000. And I'm going to go into Decimus to solve this. So before you use Decimus, I want you to hit the wrench and make sure that you are in degrees. The problem's asking for degrees, you're going to be in degrees. If the problem wants radians, make sure you're in radians. But for this problem, we will work in degrees. Hit the functions button. There's your inverse sine. 3200 divided by 11,000. And that looks like 16.912 degrees. Since this angle is between negative 90 and 90, we are going to conclude that it is correct. So the inclination, or the grade, is approximately 16.912 degrees.